Okay, I hope everything is fixed. Everyone is able to hear me, see the screen also, and I have started recording also. So it should be fine. So like I said, we are continuing with the first chapter. The topic which we are dealing with right now is types of chemical reaction. Okay, and the first one we had seen in the previous class, that was combination reaction. And we are going to go to the second topic now, which is the opposite of combination, that is decomposition reaction. So before I go ahead anywhere, let me just give you a proper definition. What would you write if this comes in an exam? What would you say? How would you define decomposition reaction? So you will say that a chemical reaction in which a compound splits up into two or more simpler and in one of our previous classes, we had already seen one of the examples of this one. So I will take the same example for this one right now. Okay. And the example was, it was related to the, oh no, I think we had seen the compound, but not this reaction. Okay. So we had seen this compound calcium carbonate. Anyone remembers where did we see this calcium carbonate? What does it, where is it used?
Whitewash.
Yes. In the process of whitewashing, we had seen that. How did we form it? Anyone remembers how this calcium carbonate was formed? What was the reaction basically?
Hydroxide plus carbon dioxide will give.
Excellent, that's good. In the first step, what did we do? Quicklime, calcium oxide. That was combined with water to give you calcium hydroxide, CaOH2, right? Plus something, whatever. And then this calcium hydroxide, this is what is on the wall, and it reacts with the carbon dioxide in air during the first few days of whitewashing, and then it makes the calcium carbonate layer, which is very shiny. This is basically marble. Okay. Yes, tell me.
Hydrogen. Dying. Where will, like, never mind.
I'm not able to hear you. Pragati, there is some problem with your audio. Yeah, Pragati, are you there? So this was the one which is used for whitewashing. Not only this. Okay, so this is the same calcium carbonate we are talking about here. Okay, everyone can hear me? Confirm quickly just once.
Yes, sir.
Okay, so this reaction, I just took an example from the previous classes. I want you to be able to relate what happened earlier. Okay, so whitewashing, first what we did, we learned this one. This was a combination reaction. The first example which you see, quicklime plus water giving us calcium hydroxide, slake lime. This was slake lime, right? And this one was quicklime. So I want you people to keep remembering these things. Don't just remember it for the class and forget it later. Okay, these are very, very important reactions. You should know it by heart all the time. Okay, so this calcium carbonate which was formed, now we are going to decompose it. Like I said, we are learning decomposition reaction. So this is one compound, and I want to break it down into simpler compounds, and let's see what happens. Okay, so when calcium carbonate breaks down, it will give you calcium oxide plus carbon dioxide. Are you surprised by what happened here? Calcium carbonate gave you back this calcium oxide, which was a quicklime, which is what we started with basically to get this calcium carbonate, and it also released the carbon dioxide. Nothing surprising over here, no? Because all these compounds were involved in preparation of that calcium carbonate. So which when this decomposes, it gave us back the same compounds. Okay, so will all of you remember this reaction now? And this calcium carbonate, there is a common name for it. It's called limestone. Remember the common name, limestone. So don't call it as marble. Marble also has the same thing, but yeah, it can call it anything. But the common name is limestone. You will know it by that name. Okay. And also scientific name will be calcium carbonate. Okay. So is everyone okay with this reaction?
Yes, sir.
Okay, now think about one thing. I said that this compound was formed, calcium carbonate, limestone, and it decomposes. Why do you think it will decompose on its own? Do you think it will decompose on its own just like without doing anything? When this compound was formed, it was already stable, no? That's why it was formed. So stable compounds don't just decompose on their own. There has to be some force. You have to apply something that will cause this decomposition. So for this particular reaction, the external thing which you need to provide is the heat. Okay, you need to provide heat to decompose it. It will not decompose on its own. That's common sense, right? Something which is stable will not decompose on its own. You have to provide something. So in this case, it was heat. And with that, let me take you to the very, very important idea related to this. So decomposition reactions, I will split it up into 3 types of decomposition reaction. Types of decomposition. Okay, my handwriting today is a little off. Types of decomposition reaction. So first one is called thermal decomposition. Can you relate to what thermal means? Whenever you decompose something by giving it a heat, some amount of heat, then that kind of decomposition reaction will be called as a thermal decomposition reaction. So this classification, what we are talking about.
Sir, can you once again say what you have said now?
Yes, I will repeat that. What I'm saying is, right now we are learning this types of decomposition reaction. And I told you that decompositions do not happen on their own. So you have to provide something. So what is that something? Some kind of energy. So that energy can be in the form of heat, light, or electricity. Three things you have to understand very clearly: heat, light, or electricity. So yeah, actually, let me write it that way. So decomposition will happen because of providing heat or electricity or light. Three types of things we can give. So when decomposition has happened because of providing heat, it will be called as thermal decomposition reaction. When it is because of electricity, then it will be called electrolytic, YTIC, electrolytic decomposition reaction. Okay, and when it is because of light, it will be called as photo. So sometimes you may say just photo decomposition or photolytic decomposition, like that. Okay, so let me write it as photo, LYTIC, decomposition reaction. Okay, everyone is okay with this idea?
Yes.
You need to give something, some kind of energy, either heat, electricity, or light. Based on what you are giving, there is a type of decomposition reaction, and that's what you are calling as thermal, electrolytic, or photolytic decomposition. So even though you do not need, I mean, since this is not there in your NCRT, so you may not need to define all these, but you need to know, okay? You need to know that decomposition reactions can happen because of these three things, and based on that, there are these three names, okay? So I will give you separate examples for each of them. So I will take thermal decomposition reaction. I'll give you some examples for that. And let's start with that itself, okay? So thermal decomposition. So the first example, basically just now we saw. What was that reaction? Calcium carbonate. When you gave heat, it broke down into calcium oxide and carbon dioxide. Okay. Fine. So let me give you some more examples. Okay, so this name of this compound, let me write it here. This compound is called potassium chlorate, CHLORATE. RATE, potassium chlorate. This one is potassium chloride. Everybody knows potassium is K, right? K stands for potassium. When it reacts with chlorine and oxygen like this, you call it as potassium chlorate. And when oxygen is released from here, only potassium chloride is remaining over here. And then oxygen gas is released into the air. Okay, so now you have two reactions of decomposition by heat. Let me give you one more example of this one. Okay, so this particular reaction, I want you to remember a few things about it. The name of this compound, ferrous sulfate. And this compound is green in color. Okay, this is green color. And this one, remember guys, what is the name for this one? Anyone remembers the name for this compound?
Ferric.
Ferric oxide, sir.
Yes, very good. This compound is ferric oxide. And it is brown in color. Do I have brown color here? Okay, let me use that. So this is ferric oxide and it is brown color. Okay. Not just writing in brown, green. Okay, this compound actually is green color. This compound is actually brown color. This is your sulfur dioxide and this is sulfur trioxide. So ferrous sulfate broke down into these three compounds. Why? Because of heat. So because of it is because all these three reactions, they are decomposing because of heat. That's why they are examples of thermal decomposition. Okay, and they are all, of course, examples of decomposition reaction.
Sir, is the equation balanced?
No. You tell me, is it balanced?
No, sir.
How will you balance it? Tell me. What's missing? You just have to put a 2 over here. Now it's balanced. 2 atoms of iron, both sides, 2 atoms of sulfur, and 8 atoms of oxygen. 3 plus 2 plus 3. Okay, now it's balanced. So I will write one more example. Try to remember as many as you can, okay? You never know. So I'll give you this example also. Lead nitrate example.
Sir, what is PB?
PB stands for lead, okay? You know about lead, right? Actually, the scientific name is plumbum. That's why Pb is a symbol, but in common language, we know it as lead, okay? And it's very poisonous for humans.
Yes, sir.
This breaks down to lead oxide. Okay, remember this reaction also well, okay? Because it has some color associated with it. So sometimes they ask you that there is a, like for the previous question, they'll ask you there's a green compound which turns into brown after decomposition or giving heat. What compound is that? So by that also, green to brown, try to relate to this equation, okay? Ferrous sulfate to ferric oxide. Same way in this lead nitrate solid, when you decompose it, it breaks down to lead oxide, nitrogen dioxide, and oxygen. And here, this compound, this nitrogen dioxide, this is brown in color again, okay? This has brown fumes. This is gaseous, this is gas, and it will be of brown color. And since it is gas, that's why you are reading it as brown fumes, okay? So now you have 4 examples of thermal decomposition. Now let's take up some examples of decomposition by electricity, which is electrolytic decomposition. So you just don't think that, okay, there are decomposition, then 3 types of that. Just remember all these things as decomposition reactions. Remember that they happen because of different types of energies, because of different reasons. So one decomposition, then let's write okay, this reaction might be interesting for you because it's available everywhere. And when I saw this reaction, even I was very excited. I wanted to do something with this. So first example, let me take some space over here. Yeah. So everybody knows what this compound is, right? You take water, and when you provide electricity to it, decomposition happens.
Sir, we should represent the liquid with AQ nozzle.
See, if it is, yes, when there is some different compound mixed with water, then you call it as aqueous, okay? Some other solid or something else, some other thing mixed up in water, not only solid, any liquid or whatever, when it is mixed up in water, then you write it as aqueous, okay? But when it is the water itself, when it is water itself, which is totally in the liquid form by itself, okay, then you write it as liquid, pure water, not mixed with something, okay?
Okay, sir.
Even other things can be purely liquid. In their liquid form, you will write them as liquid. Aqueous, when you write it, when you have a mixture of water, okay? Most of the things, yeah, go ahead.
So while writing mercury, we'll write L or AQ.
Mercury will not be normally mixed with water. You will not mix up with water. So I don't remember seeing any mixture of aqueous mixture of mercury, okay? So
it's only L, sir.
Mercury is actually semi-solid, so yeah, you'll write it as liquid only, but I will confirm that. I have not seen that mercury reaction anywhere so far. I don't remember. Like, I don't know if I told you people, I'm not an expert in chemistry. My specialty will be physics. Okay, so if you ask me questions with physics, I can give you answers straight away, all the things. But chemistry, not everything. I don't know everything. So yeah, mercury, it is in semi-solid state. I mean, but it is liquid. Okay, it's considered as liquid. So if you need to know, I will check that. Okay, whether you should write liquid or not. But that will not be aqueous. Okay, I've never seen mercury mixed with water for some reaction. But we'll see if it comes up. All right. So what? Okay. So let's get back to our electrolytic decomposition. I was talking about taking water and decomposing it with electricity. What do you think will happen? What compounds do you think will get when you break down water? Any guesses?
Oxygen and hydrogen.
Yes, very good. Oxygen and hydrogen. Perfect. Absolutely right. Hydrogen and oxygen get separated. You get hydrogen and oxygen. And I want you to balance this reaction quickly, very, very fast. Do it in your notebook and tell me what will be the balanced chemical reaction for this one. H2O breaking down into hydrogen and oxygen.
Sir, 2H2O and 2H2 this side.
Yes, that's absolutely right. So there are 4 atoms of hydrogen on both sides, 2 atoms of oxygen on both sides. So this is balanced now. Okay. So you see, you can take water and decompose it with electricity to get hydrogen and oxygen. Both of these are very, very important compounds. You know that, right? Hydrogen gas is also can be used in so many things. I think this is also used as a fuel for rockets or something. And oxygen is also used like that for fuel. And of course, we breathe in oxygen, so everybody knows oxygen is how important. And we have an ocean full of water. So look at the possibilities. Do some research. Okay. Figure out some way to do this cheaply so that everybody can get this out. Okay, so how is this electrolytic decomposition happening is, let me give you some idea about it. How do you prepare a setup? So whenever you want to decompose something with electricity, what do? You take a beaker like this and you will have a battery connected to that. If you want to give, yes. So this process is called electrolysis. You have seen this before in your earlier classes, right?
Yes, sir.
Yeah, okay. So that's
Yes,
good.
sir.
So when you do electrolysis, there are these 2 things over here, what I'm writing. Anybody knows what are they called? What you dip in the electrolyte? What is this thing called? Okay, this should not be same color. Let me put something else. Yeah. Okay, don't worry. I will tell. So let's say this is connected to a battery or something. Okay, so the liquid which you have inside over here inside this thing. This is an electrolyte. In some other processes, it will be something else. But since we are doing electrolysis of water, so for us, this thing will be water for us for this particular experiment. And then these two things which I have dipped over here, these two rods, they are basically called electrodes. Okay. And one of them is positively charged and the other one is negatively charged because batteries have two terminals, right? Yes. Say that again.
Cathode and anode.
Yes, that's good. So electrode in general, but electrodes are of two types. Of course, one of them will be positive. So the positive one will be called as anode and the negative one will be called as the cathode. Okay. The one which is connected to the positive terminal, that will be called as anode because it attracts positive charge. Anything which is positively charged, that will be attracted towards this. That is why it's called, this one is cathode actually. The one which is connected to the positive terminal. Okay. Fine. So that was a little bit of idea about electrolysis of water. Okay. And then you can collect your hydrogen and oxygen along. Let me give you a couple of more examples for that. Very quickly, I will write these examples and then we'll end the class for today. Okay. So sodium chloride, again, you see I have written liquid over here, not aqueous. You can actually make an aqueous solution for NaCl also. You can mix water with it, then you will call it as aqueous. But this is not aqueous, this is liquid. You take pure sodium chloride and you melt it by heating or whatever, okay? In that molten form, you will call it as liquid NaCl. So I think this example will make it more clear, like how to differentiate between liquid and aqueous, okay? So NaCl breaks down into Na and sodium and chlorine. Let me give you one more example. Okay, again, this one is not balanced. So balance it like this. Normally for electrolysis, you have to take the liquid form of whatever it is, okay? That's why you are seeing liquid everywhere for all these decomposition reactions with electricity. And I want you people to keep these two reactions in mind and see what happened here. You took this sodium chloride salt and you separated the metal out of it. Sodium is a metal, right? we had seen in the periodic table, it was on the left-hand side, Na. So it's a metal. So this metal is separated. So by electrolysis or electricity, you can take some compound and separate a metal out of it. Here you see aluminum is also a metal. If you want to make some utensils out of it, if you want pure aluminum, what do? This is one of the ways to obtain a pure aluminum from a aluminum oxide over here. Okay. Okay, so I will stop here. Anyone has any questions, you can ask me quickly. Otherwise, that's it for today. Okay. So we had seen two types of decomposition, thermal and electrolytic decomposition. I'll give you a couple of examples of photolytic decomposition also in the next class. We'll be done with decomposition. We'll continue with displacement reaction after that. So I'll send this note, and I want all of you to write and practice all these chemical reactions. No, see, chemistry will become very easy if you spend a little bit of time on it. And start doing from now itself. Don't wait for the exams to come. Take some rough note. Practice these chemical reactions, okay? So I give you combination reactions, practice those examples. Thermal, not only thermal, I mean the decomposition reaction. Take all these examples and practice and try to remember all of them, as many as you can. Okay, so that's it from my side, guys. I'll see you all tomorrow.
Thank you, sir.